So greetings, folks. My name is Martin Farley. I work in London at University College London and King's College London, and I work around sustainable labs and green labs. I've been working on this topic for almost 10 years, and I have to say it's fantastic to hear all the stuff that's going on. It's just really impressive, honestly. Awesome. So I won't go into this, but I think it's always good to start with a few stats. I wanted to say we don't know the full carbon emissions of science. We haven't figured that out yet, but we do know that it's around 2% of the world's GDP and around 0.1% of the world's population were researchers, at least in 2013 when UNESCO were reporting on it. You've spoken about freezers. We each know that each one of those -80s uses about as much energy as a house. A fume cupboard uses 2 to 3 houses worth of energy, very energy intensive spaces. And this is a fun one where they looked at the rate of scientific output growing, and it grew by 8 to 9% every year, which gave a doubling time of just 9 years. So we are producing a huge amount of science, and it is growing very, very fast. In terms of, this is just some updated figures. It's just to show you that essentially the rate of growth of science is outpacing the global economy still. This is, again, from UNESCO, and they were showing the percentage of GDP that's going into science. You can see Germany is very high, actually, and the UK is admittedly low. The UK really wants to put more money into science to catch up with Germany, actually. Very quickly, I just want to talk about this. I take a lot of my figures from UNESCO. They have this really interesting report on the state of science, but they were looking at the directions of science. And most of the research we do is around health. But I think they pointed out something really interesting, which was that in 2019, there was 147,000 articles on AI, but just 2,500 on carbon capture. And of course, they were saying that that was slightly imbalanced about what we're doing with our science, because essentially it is a tool and it's as good as we make it. Now labs. Labs are very energy intensive. They use around 3 to 10 times more energy than typical academic spaces, but it can be a lot higher. It can be lower as well. At UCL, around half of our energy is going towards our labs. So they are the elephant in the room for us if we're going to hit our sustainability goals. Now, sustainable labs and green labs is quite this big topic. We use those terms interchangeably quite a bit. And I think green labs is coming up a bit more. Green chemistry, there's, it's around the replacement and substitution of harmful chemicals for less harmful ones, be it for us or our planet. And then there's the built environment, which ties you in a lot in terms of your energy consumption. But in terms of your carbon emissions, your overall carbon emissions, and the operations and the equipment and the consumables you use is the larger impact. So what I'm trying to say is you have a big impact. Even if you're in an inefficient building, you can have a significant impact in terms of how you use it and the way you interact with it. I should put transport on there as well, actually. Anyways, the actions you take are very important. Now, to be honest, I think the last talk gave a good feel of this, but it was just to say that we're not alone. There's the Max Planck Sustainability Network, there's Green Year Lab, there's CELS, and there's Green Labs Austria. There's more national networks now. There's a lot of people doing things around sustainable labs and green labs. Most big institutions seem to have some sort of program going now, which is fantastic. And there's a lot of momentum in this space. There's consultancies. There's a podcast called The Caring Scientist, if you're interested, which talks about sustainable labs and green labs, which is run by Nicolina in Denmark, and also another, her name is escaping me, but yes, 2 people involved. But there's a lot going on in this space. So, I'm going to give a shout out for our own network in the UK, Lean, a very organic network, I have to say. It's a group of us that have been essentially meeting and just sharing good practice, putting our resources online, not too dissimilar to what you all have been doing here today. We put a website up quite recently. Admittedly, it looks like you're preparing sushi more than doing science, which we realized later. But the point is that it still shares good practice, and we try to put things on there, not just our resources and stickers, but things like job descriptions. Because a lot of people have been moving away from science towards these roles like I have around sustainable science. And I think it helps to see the job descriptions and what other people are doing to validate why we should invest more. You heard from Jaime just now about the need for resource to bring these networks together. Seeing these job descriptions, I think, can help validate why other institutions should invest. And you just save money when you invest in these type of folks, honestly. I mean, I'm biased, but yes, it makes a difference. Now, ooh, okay, well, it didn't come there, but anyways, it's missing there. But the point here that I wanted to make is about the scopes of carbon, just to set the scene a little bit. There's 3 scopes of carbon. If you hear about these types of carbon, carbon emissions, 1, 2, and 3. 1 is if we were to start a fire here, that would be smoke going up, and that's carbon directly into the atmosphere. 2 is the energy that we use, so the lights that are on, and etc. And those are the scopes of carbon we usually focus on, to be honest. When you hear about net zero pledges, they're all about scopes 1 and 2. But actually, scope 3 is the other, it's all the stuff that we use. It's the materials, it's the, it's the microphone, it's everything. And that pie chart there is the estimated total carbon emissions of the institution I work at, which is UCL. Now you can see there, that big purple chunk there is the products that we buy. And then the smaller, blue one is our energy consumption. And admittedly, most institutions, when we talk about net zero, it's that smaller blue one. Admittedly, that one is smaller because we pay for our electricity to come from renewable sources, not our gas, because that's not, we know this, but our electricity we can pay to come from renewable sources. In terms of the products we buy, though, it's very tough to come up with that figure. But when we looked at it remember, half of our energy was coming from labs, half of the carbon emissions there from just under half of the products we buy were coming from science facilities. So in terms of our carbon emissions, again, what I'm trying to say is that the stuff that we use, the material consumption associated with science is a big impact. I quite like the talk earlier this morning about the chemical management system, for example. That was a really good example of taking that into account, because obviously that's not energy consumption. That's a different bag of fish. So we're trying to come up with targets around this, but admittedly, it's very difficult. And it's difficult because nobody knows. This is oat milk. I think they were serving oat milk here. It was, yes, which is great. Oat milk, this is Oatly, Swedish company, and they put in very tiny, tiny, tiny letters there, a challenge to the milk industry, which says, this is the amount of carbon per kilogram in our oat milk. And they know that their figure is going to be much lower than cow's milk. But we don't have these figures for other things. We don't know. We don't have these figures for anything we buy, essentially. So it makes it very difficult to estimate that. How do we know what the actual figure is? Because we've done it based on our financial spend, but we have to make estimates. And that's in part why we don't have a lot of targets around scope 3. But it doesn't mean we shouldn't be taking action. Now, there's a lot of confusing stuff out there, and being sustainable in the lab is not easy, in part because there's this constant balance between energy consumption and embodied carbon. And this is a tougher example of it, and this is more what I would call it's a tough word, but it's on the greenwashing side, I think. I don't know if it's intentional, but this is this constant balance. So, if we want to make our buildings more energy efficient, we can do that, but it often requires rebuilding the building or refurbishing it. So we can get more energy efficiency, but the grid tomorrow is going to be more efficient because we're going to have more renewables coming online. So how do we take that into account? It's not clear. We don't have all the answers yet. Does tearing down all of our buildings to become more energy efficient, is that the solution? Or that balance between embodied carbon and energy consumption is, I find, one of the biggest challenges in sustainability moving forward. Because it's not clear, we don't have all the answers here. This company here was marketing single-use mouse cages as more environmentally sustainable. You can see the little emblem, the little green sign there. And they were doing that because it means that you use your autoclave less. You run less energy on site. But of course, we know that produces a mountain of plastic somewhere else that we don't see. And so that's, I think, an example of where a company hasn't taken into account that balance between embodied carbon and energy consumption. And that is no good, I have to say. That's not what we want. But it's not clear, maybe it wasn't intentional, et cetera. this is a company that's trying to look at that a little bit more. You know, we hear about tip boxes. Well, this is a company that tried to produce, or has produced, a tip washing machine. And so that you can reuse your tips, and it only works for non-filter tips, and it costs money, and it needs to be managed, and et cetera. But they did do a life cycle assessment on the manufacturing of that piece of equipment. And you know, we're looking into buying one at UCL. I'm excited to give it a try. You know, there's a lot of challenges around this type of equipment, but I really think that's the direction that we're going. More on-site services. And I don't know if you've had this, but in the UK, we couldn't get a lot of consumables about a year ago. The labs couldn't get enough tips and et cetera, PPE especially. So, you know, the more products like this that we have that we can become self-reliant, you know, this is a business continuity thing as well, but it's a sustainability thing especially. This is a paper that I worked on with a colleague, Benoit Nicolet, and essentially this is trying to look into what we were describing, this balance between embodied carbon and energy consumption. So if you use your autoclave and your washer more to reuse your consumables, is it actually better? Well, we did the life cycle assessments, and essentially what we found was, yes, it was better. It was, you know, kind of expected it, but I mean, you inherently expect this. We do our dishes at home. We don't throw out our dishes at the end of every meal because we have a feeling that that's probably not the best way to do it. There's other issues around reuse in labs. I'm aware, contamination, and we're not going to get rid of single use right now. But we did look at items that you can commonly reuse and replace, you know, so things that you could replace tomorrow, glass pipettes versus, you know, et cetera. Falcon tubes. You can introduce glass falcon tubes for some causes again. So we also looked at the costs, and we found that actually the costs were either comparable or you saved money because consumables cost a lot of money. So you know, we're trying to give the evidence out there, and you know, that I think we need more research like this, to be honest. And again, I'm biased, but exactly, yeah. Anyways, we need more research like this, and we hope to see more studies of this sort, life cycle assessments. Now, oh yeah, these are just the other, yes, figures that I forgot to click through. You can see the cost again. Anyways, the more you use, the more carbon you save, et cetera. So, and you can reuse plastic or glass as well. You know, so a lot of plastics can be autoclaved. Now, more research is needed. We have a lot more questions in the sustainability of science. What is the embodied carbon of liquid nitrogen versus an ultra low temperature freezer? I don't know. What is, you know, why did we, well, I can talk about -80, but what are the embodied carbon, what is the embodied carbon of a lot of the scientific processes that we do? We don't know the embodied carbon of the chemicals that we use. You know, we have an idea of some of the solvents maybe, but, you know, a lot of them are unknown. So, with the rate of growth of science, I think we need to start asking these questions, and there's a lot more to be done. We need more life cycle assessments, and it's early days. That being said, in the UK, it was great to see this because this was a £1 million grant that the Medical Research Council put out, and this was the first grant I'd ever seen of its kind, where essentially the Medical Research Council said, we don't know how to do net zero science yet, so we're going to put out £1 million or £100,000 per study. For you to tell us a bit more about answering those questions. So this grant's closed, and it's underway. We put in a bid for actually looking at the liquid nitrogen versus freezer question, which we're hoping to get approved. So there's other research going on in this space, but I think it's really validating of the questions that we have when a large funder puts out funds like this, and to say, help us study it, help us figure it out. Now, we need more research, but we need action now. We definitely need action now. If you're here, you don't need me to talk about it, but you know, the most recent IPCC report came out, and our timeline is not, it's not on our side. And in that sense, you know, we need to enable as many actions as we can in the immediate. In the UK, we have a net zero goal for 2050. Our different institutions have various net zero goals. At UCL, we have one for 2030. And actually, the one in the middle there is in some ways the one I find most interesting, because it's UKRI is our largest funder in the UK, and they have a net zero target for 2040. don't know of another funder that has a net zero target like that. And again, this is so validating for the work that we do. When a large funder comes out and says, you know, we need to facilitate net zero science. You know, it's really been it's opened a lot of doors, I think, and it's helped put it on the map. They're going to be coming up with targets because, in a lot of ways, you know, we've heard about the challenges of resource, and we kind of know that, you know, the funders decide a lot of things. When the funders say you need to do this way, people often listen because, well, they need funding to do research, and it's very competitive for that funding. UKRI has said they're going to put in targets around this space. With that in mind, a few years ago, we were thinking about how do we get targets in sustainability targets in funding. Years ago, when we were starting out with Lean, we went to Wellcome Trust in the UK, a big funder, and said, can you put in targets around this? And they said, you can't tell us what a sustainable lab looks like, which was a fair point. The other analogy I like to give is that, you know, when we wanted to make science safe, we didn't say, everybody go and do your own safety standard. No, a central standard was produced and people assessed against that standard. In the UK, when they wanted to promote gender equality, they didn't say, everybody go, you know, figure out your things around gender equality. Sally Davis, the chief medical officer at the time, said, if you don't meet a certain level in Athena Swan, you're not getting funding. And everybody started improving their conditions around gender equality. For some reason with sustainability, we've left everybody on their own to figure themselves out. Everybody needs to go and learn how to do this from, you know, bottom up, and we don't have time for that. We need action now. So it's a long-winded way of me saying this is LEAF. LEAF is the standard around sustainable lab operations that I've been working on from UCL. And essentially it's trying to say, okay, if you work in a lab, what can you do to make your lab more sustainable? So we put in actions around the things you might expect. You've heard a lot of great examples today, you know, things like ventilation, equipment, people, et cetera. Broken up in bronze, silver, gold, user-led. You know, this is really from users. We always engage users who are using the tool about how to improve it. And there's some calculators in the tool that allow you to estimate the carbon and financial savings because, well, we know that senior administrators often talk in not a language of, right, anyways, money talks, and showing the savings that people save, which they do save when they do this stuff, it helps. Now, I'm talking about research quality. I think that's one other angle that I want to bring up because, you know, we put these criteria around research quality because of this common ground between reproducibility and accessibility and sustainability. And essentially the argument that more reproducible science is more sustainable science. For the amount of resources we invest in science to produce our data, of course, we want that data to be reproducible. And so that represents a better investment of those resources. There's also this common ground in the sense that the mechanisms of improvement are you know, similar. It's good lab practice leads to more sustainable labs, and good lab practices often lead to more reproducible research. I usually do a quiz when I do this talk. I've spared you from that. But one of the questions I ask at the end is, what percentage of the research that you've done do you think is accessible and reproducible? And I don't have an answer for it, but I'll tell you that most people answer, nobody answers above 30%, to be honest, which is, I think, pretty interesting when we think about how much we put into science to get that much in return. So anyways, we get a lot from it. I'm not trying to say there's, you know, there's other reasons, but it's an interesting equation that we don't have the answer for. So that's why we put in criteria around research quality in this space, and we're working on developing that more. So these are some examples of LEAF criteria. You know, I think the actions there relatively straightforward. These are good, you know, easy examples. I didn't put up the research quality criteria, but one that I'm kind of interested to add this year is, do you have a system in place to promote the use of existing data? We talked about, you know, that rate of growth of science, how much data we're producing. Are we using it all? Is it all accessible? So it's, we're interested in exploring that more. I got to say, we piloted Leaf for a few years, and we piloted it when it was an Excel tool, and huge standard deviation in the savings because labs are different and people were doing different things. And there was also a pandemic. But we found that people saved. Some saved very little, some saved a huge amount. It really depended on what they were doing. But it was a positive experience, hopefully, for those that participated. We put resources online, and we need to develop these resources more. But we put out an equipment guide and a plastics guide, and you can find these online if you're interested. But essentially, these are resources. This one we need to update, I have to say. But everything we need to constantly update, because we just want to put out the good practice, and make it accessible. Because yes, and also there's a criteria, for example, on reducing single-use plastics. Well, that changes in every setting you're in. You can't save single-use plastics one way, the same way in each lab. So we put in a guide around that so that people can hopefully get inspired. Okay, this is what a criteria looks like. That's kind of boring. This is what a calculator looks like. We have these calculators. The idea is that you fill these out and then you fill it out again, but you change something. So maybe in this case, you put some of your clinical and hazardous waste into the recycling, and you save some money and you save some carbon, and you can estimate those things from that. And then, okay, this is from a fake lab, but you can see some of the savings all together, and then you can approve it at the end, and somebody gets a certificate, which is important. Actually, I always forget to mention that you get a certificate at the end of this, but it's actually really important, I think, to acknowledge people's work, to standardize it, and it is a really important part of this, to say that you've done something good, and yes. Little points just to, brag, because I'm sorry, but Leaf's been online for a year, and it's crazy, I have to say. The reception has been, it's taken me back a little bit. So we're working on supporting it more, but Leaf is now in 70 institutions in 12 countries. It's the world's largest green lab program somehow. And we have over 1,000 labs signed up, and particular kudos to universities of Exeter and Bristol, which had 100% uptake across their institutions, which is just really impressive, I have to say. And we've been supported by these, some efforts like the UKRN, which is the UK Reproducibility Network, which helped us craft some of those criteria around research quality, and the National Technician Development Center. I can't emphasize how important our technical community is to sustainability. Such an important resource. Lab management and technicians really are. They understand lab equipment. They're managing things. They understand how to produce good data. They are such an important resource in this, from every step along the way, that we're going to need to invest in more if we're going to get towards net zero science. Okay, whatever. How does it work? Well, oh, it's not catching up. Oh no. Okay, well, I can finish this one just by describing. How does Leaf work? Well, one of the main parts I just want to say is within the tool, we've put in a peer auditing tool so that labs can assess each other. At big institutions, when you get a lot of labs, it becomes a lot to assess them all, and resource is an issue. Very quickly, I will just say about Leaf, one thing I do want to mention is we put in this peer auditing feature, because if you can imagine, we have a lot of labs, and we have hundreds of labs in some of our institutions, so assessing them becomes a big task. So we put in something so that labs can assess each other, because you can imagine actually that relieves some of the administration, but also it gets labs sharing good practice and pushing each other. Often people that work in labs are the most qualified to assess each other and to promote good practice in that sense. So that was essentially what I wanted to say about that tool. Last thing I'll just say is I think it's win-win when we integrate this type of stuff. Everybody benefits, particularly I think the technical staff are a really important part of that I mentioned before. University of Exeter, when they implemented Leaf, they went through technical services. They actually didn't go through a sustainability team or through their, the researchers were involved, but it was the technicians that really led this. And I think it's been hugely validating that the Medical Research Council put Leaf in their own labs. I'm hoping that this is a sign that the funders are essentially saying, let's get our house in order before we tell others that they have to. That's hopefully the direction that this is going. and they put it in their Antarctic labs as well. They have this little lab up in the Antarctic, which is British Antarctic Survey, so they can be a tiny bit more sustainable as they watch the temperatures rise. Sorry. Anyways, lots of folks to thank. Thank you guys for hosting. Really appreciate it. Thank you, Jan, Jakob, Martin, and Pamela, of course. And I'll pass over to you.
Okay, there we go. So hello, everyone again. For those of you who didn't see me yesterday, I'm Pamela. I'm the coordinator of the sustainability group here in the Institute for Biophysics. And I want to tell you today a bit about the work we have been doing now with LEAF. We started looking into this by mid-end of last year, and we have been very slow with the implementation. So I cannot really talk to you about the results yet, but well, maybe if you're considering to take it for your institutes, maybe you can learn it from our experience and how to deal with it in a Max Planck kind of way. Okay, so we got into this because as many of you have already mentioned, sometimes we have these groups, we have a lot of ideas. Someone mentioned today about the low-hanging fruits, and we had the sense that we needed to give our projects a bit more of a direction. And we knew which topics were important to us, but we couldn't really decide where to put all of our energy. And we came up with the idea that maybe trying to get a certificate for our laboratories will be a good idea to set up very specific goals. So with this in mind, we knew that we wanted to focus in energy, waste, and equipment efficiency. So we started looking around for certification programs. Sorry. And we came up with these two, My Green Labs and LEAF. And I will not go so much into the details of one or the other, but we were able to meet with both teams several times, and we discussed the needs we had for our institutions. And so I think by the end of the summer of last year, we ended up meeting with our directors and presented them both ideas and the reasons, benefits, what this will be good for our institute. Long story short, we decided to stick with LEAF because they have a lot of focus on environmental footprint and reducing the costs. Which talking about costs, that was really good to sell the idea to our directors. We like LEAF over My Green Labs because it's developed by scientists for scientists, while My Green Labs, we felt like it was more made for the industry, and most of their users were actually like very big companies at the moment. We like that it's aligned with the research, global sustainable development goals. We like, as Martin already mentioned, there are a lot of shared resources that we have been able to use, like posters and guides, and that they also take in consideration our own initiatives. So even though there are a set of criteria that we have to comply with to get the certification, there's also an area where we can explain the things that we are doing on our own. So to ground it a little bit, what we're doing here, we're of course interested in getting all of our labs certified. As I mentioned yesterday, we have a lot of independent groups and the departments and facilities, so it's a lot of room to cover. But for now, this is what our map looks within the LEAF platform. And yeah, as you can see, it's way less than what I showed yesterday, but at the moment we're just focusing on the labs and which have members that are participating in our sustainability group. And so far, we actually have been only able to get the base calculations for 3 of our labs of the Department of Structural Biology, where I'm working in, the Department of Social Biology, and our microscopy facility. This is what one of the calculators look like, and this is just an example of the work we have been doing. We put just some time to go into the labs and check from all of the areas we have in the calculators. Thank you. And there are several things that you can consider, for example, the freezers. And even though we knew we were going to have some problems, things that we knew we were going to like, we were very surprised, for example, with the -20 freezers, because we found from here, this is just from one of the labs, and we see that the -20 freezers, 11 of them were at -25 degrees. So we have completely unnecessary waste of energy here. And then again, this is only one lab. So probably this thing is going on in the whole institute. And I'm even ashamed to say that at the moment we found one that was a -32, which is just insane. just putting it to the limit of what can be achieved. So yeah, just to come to an end now with a few calculations that we have made so far. Now we have kind of a guide with specific goals that we want to achieve. So we know in terms of waste that we have to work more on separating the plastics in the labs. As I mentioned yesterday, we have been implementing more Verpackung bins in the kitchens and in the office side, but this is not the case yet in the laboratories. We also know that we have to get into purchasing, because at the moment we are not really considering efficiency and recyclability when we are talking about chemicals and everything in the lab. Also, equipment, as I just mentioned, we really have to get on board with the cold storage. We also have a lot of -80 freezers that we know we could reduce the temperature. And besides this, also, we are really looking into sharing of chemicals and protocols. Just as a talk we had this morning, we have, of course, list of the chemicals that are in all of the labs, but we don't really have a mechanism for sharing them, even within the whole institute, besides only writing emails at the moment, which works, but it's not the most efficient way to do it. Something else that we have in mind, or we have agreed within the group, is that we don't want to become the sustainability police. So at this point, we just want to inspire all of our colleagues. So even though we see that there are -25 freezers out there, we don't want to go and, of course, reduce the temperature ourselves or be harassing the people like, you have to change. So we want to, for now, just focus on getting the information out there, telling people why they should make these changes, and hope for the best. Also, yeah, we want to include more research groups into the program. As I mentioned, we are only a small group, so we're tackling our labs first. So with time, we're going to try to get together with other research groups, even if they don't want to join the sustainability group per se, just to have someone who helps us go around their labs and explore, so that we're not so invasive. Also, I mean, this is all focused on the chemical labs in the wet labs. But as I understand, also LEAF is trying now to implement more stuff for IT and theoretical departments. So we're really looking forward for that, because we actually have members in the sustainability group that were really excited about this at the beginning, but then we kind of left them out. And yeah, yes, I say get in touch with more people outside of the sustainability group. So yeah, that's all my feedback that I guess I can give for the moment. And yeah, if you guys want to know anything else about how to approach this from the MPG, just ask us. Thank you.